Okay, guys. Passive, active. What are these? Passive or active? It's a carbon fiber product, a reinforcement, a rebar, if you will. Look at that. It's flexible abilities. You can flex it. It's very strong. The strength of reinforcement, trying to get rid of something here, is it has to bond with the concrete for it to work. That's why you have the profile. Has to bond with the concrete for it to work. It has to be located in the part of the concrete that will experience the tensile forces. If it doesn't bond, as the forces come down, let's say right here, if it's not bonded, you get flexing of the reinforcement. You'll get flexing of your reinforcement if it doesn't bond. If the load's here and it went with the concrete, it would do that. The concrete can take its load, just whatever the load may be that you apply to it. At the point that it starts to fail is tension, right? It fails in tension. The underside of it will be the tension side of it, if you're putting the load at the top. If this was not here, the concrete would just fail, crock right through, and you're done. You place this in a part where you determine that the tensile forces will be experienced, and you counter it with this. So instead of the structure being able to open up at the base, let's see, like that, it can't open up if you put reinforcement inside of it. To a degree, it can't open up. It will resist. That the tensile forces will resist without cracking until you supersede the elasticity of until you push this into an elastic point where it's going to crack the concrete. The point you're cracking the concrete, the rebar is still working. If it's bonded, it's still holding, but your concrete has a crack in it now because it experienced a tensive moment inside of it, possibly not to the point of equal with the reinforcement failing. So possibly meaning most likely all the time that your cracks in your concrete fail because they still will experience a tensive moment. And it could be side to side, not just the force is going there. They want to pull this way and that way. And it doesn't take much for it to get that hairline crack to do it. And yet your rebar still is working now. Your rebar is working at that point. And you got that crack there, it's working. And as long as the loads are on it. If you cycle it off, so in other words, you got that tractor trailer on it, it caused a crack, and you cycle it off, well, the concrete might want to rebound back to where it was. And if you keep cycling it, you can imagine that you can break your concrete up pretty damn fast if you keep cycling it. You don't want concrete to cycle. You don't want the concrete to flex. You've been on decks where they move. That's all the entire deck moving. That's not a rippling effect of the deck. You don't want that. Your concrete doesn't have the flexibility. Post-tensioning is an act. So this is passive, right? It's just waiting to be used. It just sits there doing nothing. It's just flexed. It's laying there. It's nothing. It sits there waiting to be used until it gets loaded to the point where it can be used. Post-tensioning, on the other hand, let's pretend like it's post-tensioning, is elongated. When it does that, it creates a force, a clamping force in the concrete, and the concrete was referring to. And Hooke's law is what I triggered one of the other engineers over there on, that he doesn't believe it's Hooke's laws. Now maybe he does now, but so it's an opposite. Nothing's for free. Everything's opposite and equal. Opposite and equal, unless it's a relationship. Sometimes that's not opposite and equal, but and forces, it's opposite and equal. For me to bend this up to this, what you're looking at, it required me to create the forces in each one of my hands to do that. At the same time, it wants to straighten back out to there. So it's applying an equal amount of force on each one of my hands to straighten back out. If I turn it over the curvature now, it now has even more force. The profile wants to push back on me even more. And that's profiling. But now the elongation happens when you put the cable. It's an active system. It's not passive. Post-tensioning isn't. When you elongate it, it puts the force in there at where the tension might be. You predict where the tension will be in the pad. you then counter it before it even gets to the point of cracking. You counter it and say, well, I'm going to put that in compression to be able to take a compressor that it will not get a crack in it, that it'll be able to take, 4,000 pounds per square foot before this will elongate. Once this elongates, if it's already in compression, if you get it to elongate, you create a crack in that deck with this in there, a crack on the underside of it, the tension crack. You've now elongated your cables. You've exceeded their ability to stay in a clamp force. If you get a crack, you've now understood that you on the bottom of it, then you understand what happened. Now, sometimes people put these in the wrong location in the pad, and you can create a crowning of forces going up. It's an equal and opposite. You don't get it for free. You don't get the post-tension anything without it also having to resist those same forces that you put on it. It's got it. So you by doing that, you're also creating a stress, a permanent stress in the concrete as long as it can maintain it. And an unbonded system, you're creating a permanent stress at the end units, with a free body diagram sort of coming in towards the center of it, the forces coming towards the center. Ultimately, the center being the weakest point. If you're doing this system, you would make it so that that's the load point, that the clamping force would be resolving that major point. You got to predict where the loads are. You're gonna make it for load design loads, point loads. So hopefully that was helpful to help you understand passive and how they work compared to active, an active system, how it works. I'm trying to think if I missed anything. This is carbon fiber, like I said. It's a very interesting product. Very light, won't rust. It's a passive system. It's not active. It would be nice if you can turn this active, but then it's not for free. You're always creating a stress inside your material also. So ultimately, it's got to resist, and it wants to elongate. It wants to relax. It wants to go back to where it was. The forces are fighting each other when you do that. So, passive system versus active system. Post-tensioning, active. Rebar, passive. It will not work until it's loaded to the point where the concrete wants to crack. If you put this in the right place, it will then be the counter forces for that up to a degree. Take care. Hopefully that wasn't too confusing.